Hello dear students, today the topic of the class is IDFT using FFT algorithms. By understanding this class, you will be able to solve the problems to compute IDFT. So let us start the class. IDFT stands for Inverse Discrete Fourier Transform. As you know, FFT the algorithms are DIT and DIF. DIT stands for decimation in time and DIF stands for decimation in frequency. IDFT of capital X of k gives x of n. Inverse discrete Fourier transform of capital X of k gives x of n, that is the discrete time sequence. This is what we get after IDFT. We have to derive what is x of n. So, FFT algorithms are DIT and DIF and can be used to compute inverse DFT without any change in algorithms. So, how it is done? We have to know the formula. The inverse DFT of n point sequence is denoted by capital X of k and is defined as what you are going to get by inverse DFT, small x of n. X of n is equal to 1 by n summation k is equal to 0 to n minus 1 capital X of k w to the power of minus nk, where k is extending from 0 to n minus 1. So, this is a very important formula of IDFT. X of n is equal to 1 by n summation k is equal to 0 to n minus 1 capital X of k w to the power of minus nk. What is w? Trivial factor, its equation is e to the power of minus j 2 pi by capital N. Now, you take by taking the complex conjugate of the equation 1 and multiplying by capital N. Take complex conjugate and multiply by capital N, we will get this equation. What you have done? Complex conjugate. So, x of n becomes x star of n and multiply by capital N. On the RHS side, take the complex conjugate of it and multiply by capital N. So, taking complex conjugate, x of k becomes x star of k and w to the power of minus nk becomes w to the power of nk. So, take complex conjugate and multiply capital N on both the sides of equation 1 to get equation 2. If you carefully look, at this equation, the RHS part of equation 2 is the DFT of the sequence x star of k and can be computed using any FFT algorithm. The desired output sequence, what is the output of IDFT? Small x of n. The desired output sequence x of n can then be found by complex conjugating and conjugating the DFT and dividing by capital N to give the equation. So, we got this equation. Now, you want to get small x of n. What you will do? You have to take the complex conjugate on both the sides and divide by capital N. Yes or no? So, this equation 2 now becomes, so what is equation 2? X star. So, taking complex conjugate, it became x of n divided by capital N, and on the RHS side 1 by n summation k is equal to 0 to capital N minus 1 x star of k w to the power of nk complete conjugate. So, what you are doing? You are doing the DFT. This part is a DFT of x star of k. First find the DFT of x star of k and then take the complete conjugate. So, you will get and divide by capital N, you will get x of n. So, what is the IDFT equation now? X of n is equal to 1 by n summation k is equal to 0 to n minus 1 x star of k w to the power of nk whole conjugate. Or other way of writing this equation 3 is this equation 1. X of n is equal to 1 by n summation k is equal to 0 to n minus 1 x of k w to the power of minus nk. So, you are finding. So, as you cannot use this negative twiddle factors in your DIT and DIF flow graphs, we have to follow these two steps. This is IDFT formula, x of n is equal to 1 by n summation k is equal to 0 to n minus 1 x of k w to the power of minus nk. But using DIT and DIF, you do not have this negative values. So, what you have done? You have conjugated on both the sides and got the equation x of n. X of n is equal to summation is equal to 1 by capital N, summation k is equal to 0 to n minus 1 x star of k w to the power of n k the whole star, that is star indicates complex conjugate. So, this method is used in DIT and DIF algorithms. In the next class, we will be seeing how to use this concept for solving IDFT problem in DIT as well as in DIF algorithms. Thank you. Good luck, students. If you have any queries, post in the comments.